All right, this is day one of learning Rust. Today we'll focus on learning the basics. In the last stream, we did two questions of lead code, the most easy, basic ones. So, yeah, we'll continue with lead code using Rust. And I believe that I did this already. Maybe somehow this wasn't stored. Okay, let's continue with the easy questions. Let me open up Rust documentation. Learn. All right, cool. Now I am all set. Okay, the question is two sum. You might be very familiar with this question. So we have to find two numbers in an array that give sum equals to a given target. For example, in this, 2 plus 7 becomes 9. So the output is the indices of those numbers. Now, there are multiple ways to do this. Let me copy the example. One is we could sort the array and do something like a two pointer approach, right? That might be one option. Maybe it won't give the answer, but yeah, this is one way to do that. Second is push all of these numbers to a hash map and then check if two numbers exist. Then, like, basically iterate over the array again, subtract that number from target and check if it already exists in the hash map. And we have to make sure that the same element is not being used for twice. Basically, we should not add a number to itself to get the target. That is the goal. And only one solution exists. Okay, so what we will do, we'll do a hash map approach. So the logic behind this is we will store the frequency of each number. So for example, frequency of 2 is 1, frequency of 7 is also 1, and 11 is also 1, and 15 2. And then we iterate over 2. Since target is 9, 9 minus 2 becomes 7. 7 exists. So yeah, we have a pair. And we also need to keep track of the indices, right? Okay, we also need the indices. Okay, I'm back. I'm back. Let me also start some music, get the vibe, set the vibe. Okay, let me open up some non copyright music. Yeah, this one is cool. All right. Okay. Cool, cool, cool. So, okay. What was I on? I was on a hash map storing the frequency. But on second thought, I don't think a frequency array would be uh, required. Let's see one of my past solutions, what I did, because I'm not here to learn lead code, right? I'm here to learn Rust syntax. So we'll focus more on syntax instead of learning how to lead code. So in my previous solutions, I took a hash map. Okay. Hey, that's neat. Okay, cool, 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 cool. So what we need is we just need one iteration, right? right? So we need only one iteration and one hash map. So we'll iterate over this array and push each number in a hash map. And if we find the desired number already existing, then we return it immediately. Otherwise, we return an empty output. So what do we need here? We need a hash map. Let's try to remember how we did that. Map, right? Hash map. Hash map new, okay, equals hash map new. And now I need to iterate over nums. So what I'll do is for n in nums dot I think it was into iter, right? And then I need to check if the desired number, which is target minus n, exists in the map. So if map dot contains key, contains underscore key target minus n, then I have to return an array, right? Return an array of two numbers. We just copy and paste it here. Array. Okay, let me open ChatGPT also. I mean, ChatGPT is nice for basic stuff. You have now limited access to our latest model, GPT 4.0. It's smarter, understands. Okay, no, I don't want to try it, man. Just give me the free one, man. How to return an array from a function in Rust. In one line. Here are some examples, both fixed size arrays and vectors. Okay, so I can simply return vec exclamation and by numbers, right? I also need I, man, damn. Okay, iterate over an array in Rust with index. Array.iter.enumerate. Okay, and we will have two things here. One will be index and other one will be the value. Then if map.contains key target minus n, then return the map.get target minus n and idx. That's all, right? And if it doesn't exist, then I have to put here, I think it is map.insert the key will be the value, right? Or no? Yeah, the key should be value. Value here is n. The yeah, okay, cool. And at the end I can simply return, or maybe let's not return and check if it throws any error. Okay, it threw some error. Hash map use. Oh, okay. Let me do this. What was it? STD collections hash map, right? Mm-hmm. Expected this, found I32. Okay, I need to understand what is this borrowing? What does this mean? These are new terms for me. Okay, let's read. Borrowing versus ownership in Rust. Borrowing versus ownership in Rust. Hmm. Most of the time, we'd like to access data without taking ownership over it. To accomplish this, Rust uses a borrowing mechanism. Instead of passing objects by value, objects can be passed by reference. The compiler the compiler statically guarantees via its borrow checker that references always point to valid objects. That is, while references to an object exist, the object cannot be destroyed. Okay. Okay, so if there is any reference to an object, it cannot be destroyed. So, and reference is denoted by this ampersand. Okay, so for example, in this function, there is a boxed I32. I don't know what that means, but whatever. And we are printing it. In the next function, we have a reference borrowed I32, and we are printing it here. Create a boxed I32 in the heap and a I32 on the stack. Remember, numbers can have arbitrary underscores added for readability. Here we are creating in the heap, and then this is a stacked I32. Borrow the contents of the box. Ownership is not taken. Borrow I32. We pass a reference of this boxed I32 to this function, and then we pass a reference from the stack. Okay. Take a reference to the data contained inside the box. Take a reference to the data contained inside the box. Ref to I32 ampersand I32 ampersand boxed I32. Eat box I32. Destroying box that contains this. Cannot destroy boxed while the inner value is borrowed later in what? In scope. Okay. Attempt to borrow after inner value is destroyed. Goes ref to I goes out of scope and is no longer borrowed. Okay. So if I understand it correctly, borrowing means passing a reference to that function, and ownership means passing that object. Basically, this means that you are providing ownership to this function. Means this function can destroy this object. But what Rust prevents you to do is, if you are passing a reference to a yeah, we are passing a reference to this function in the scope. So at compile time, Rust compiler will check if there are any references of that object passed to some any function or any code block. It will prevent you from destroying that object. So this function cannot destroy this variable. I think this is what it says. I'm not sure. Let's read it again. We'd like to access data without taking ownership over it. To accomplish this, Rust uses a borrowing mechanism instead of passing objects by value. Objects can be passed by reference. The compiler statically guarantees via its borrow checker that references always point to valid objects. That is, while references to an object exist, the object cannot be destroyed. Makes sense. Okay, so what is happening here? So we are borrowing the value here, right? Argument to this method are incorrect. Target. What should I do here? What do you mean? Do you mean like this? Is this what this guy wants? No. Let's ask our good old friend ChatGPT. What is the problem in this code? Okay. Do you mean like this? Is this what you mean? Yeah. But why is that? Then what? Expected option, found U size. Okay. take a look at my previous solution, what I did earlier, right? My solution, submissions. Yeah, open. What is happening? Okay. Okay. When using a for loop, you cannot directly return a value like vec this from within the loop. Instead, you should use a method to break out of the loop and return a result. Here is a corrected version of the code. Use if let to properly handle the value retrieved from the map. Return the value using return to exit the function. Ensure the function returns the correct type. This. Here is the corrected version. If let sum. What is sum? Should I do a return? I cannot do this. What do you mean? Expected option found U size. Get function in hash map. Yep, hash map get. Returns a reference to the value corresponding to the key. I don't need a reference. Yeah, I need a reference, right? I don't need the value, right? Okay. The key may be borrowed from the map's key type, but hash and EQ bro returns the key value pair. Map dot get ampersand this. Map dot get ampersand this. Sum. The key may be any borrowed form of the map's key type, but hash and EQ on the borrowed form must match those on the key type. Okay. this, right? Return a vector that contains a value from a hash map in Rust and another I32 value. Do I need to do this? Is there any other way? Is there any other way to write this? What? Okay, let's understand what is happening here. If let sum value from map equals get map.get key. What does this mean? Explain this code. Explain this part of the code. This method call attempts to retrieve a reference to the value associated with key. Correct. The get method returns an option of %v, where v is the type of the value stored in the map. Correct. Right. What happened? Otherwise it returns none. If let sum this value uses if let syntax, which is a pattern matching feature in Rust. Which is a pattern matching feature in Rust. Alright, I'm back. Someone was at the door. Okay. Okay, where were we? We were trying to return a vector from an if condition. Okay. The get method returns an object of option where v is the type of the value stored in the map. If the key exists in the map, it returns some ampersand value. Okay. Otherwise, it returns none. If let, which is a pattern matching feature in Rust, if let allows you to match against an option and directly work with the value inside if it is sum. Okay, so if let sum, this attempts to destructure the option returned by the this. pattern matching and dereferencing. Ampersand is a reference inside sum. It dereferences the reference to get the actual value. In other words, map.get returns an option this, assuming okay, an ampersand in the pattern dereferences this to get I32, which is then bound to this. So you are saying that I need to do something like this. If let sum, and this sum will be a value from the map.get. The key is ampersand target minus n, right? And I don't need to do this bullshittery that I did in C++. Cool. If sum, and this will be the value, right? Val. Okay, can I do it like val? Will this work? Okay, expected I32 found view size. Convert index to I32. To convert a U size to, you can use as. What do you mean? As I32. Right, it's as I32. Mismatched types. Vector I32. What do you mean? Oh shit. I also need to insert map.insert n and the index. Expected vector of I32 because of return type. And what is it returning? Okay. Yes. Okay. Now let's take a look at the most voted solution. Okay. We were looking at the most voted Rust solution. I don't need all, man. Why is this? Why are these tags not loading? Bro, is my internet down? What is happening? Most votes. Okay. So he is using a hash map. He's also defining the type of the hash map. And then for iv nums.iter.enumerate match m.get ampersand target minus. Mhm. Yeah, it's kind of similar to mine, but yeah, whatever. No? It's all right. I mean, I did a good solution this time. These are nitpicks, but you could create M with the hash map. Since we know it will never be larger than nums, you can also avoid the type conversion to i32 by using zip instead of enumerate. Though that's less clear to read, finally, as others have said, panic is more idiomatic than an empty vector. Panic exclamation. Bro, like what are these keywords, man? Panic unreachable. What the hell? What is panic in Rust? making panics explicit and providing mechanisms to handle them. Okay. In Rust, a panic occurs when the program encounters an unrecoverable error and needs to terminate immediately. This is Rust's way of handling conditions where continuing execution is unsafe or impossible. A panic is a form of error handling that aborts the current thread of execution, unwinding the stack and cleaning up resources along the way. When does a panic occur? Manual panics. You can explicitly cause a panic in your code using the panic exclamation macro. This is often used for asserting condition that should never occur if the code is correct. The Rust standard library can also cause panics in certain situations, such as indexing out of bounds in arrays, vectors, or slices, calling unwrap on an option that is none, calling expect on a result that is an error. Panic handling. There are two main strategies for handling panics. So, what is unreachable then? What is unreachable in Rust? The unreachable macro is used to indicate that a certain piece of code should never be executed. It is a way for developers to express to the compiler and other readers of the code that reaching this point would be logically impossible. If the code does happen to reach an unreachable statement, the program will panic, providing a clear indication that something has gone wrong. Usage of unreachable. The unreachable macro can be useful in various scenarios, such as exhaustive pattern matching. Okay. So instead of this should be unreachable. Is this what you mean? Okay, also requires some message. I should also create some document that where I can write all of my all of the stuff that I'm learning, like all these small details, unreachable, panic, what the fuck is this? So yeah, I should note it down somewhere. All right. Okay, so yeah, it's been this stream has not been very great because I was like on and off. Someone came at the door, then yeah, I wasted a lot of time in the stream, but we'll end up with searching some of the questions that I had from my previous stream, and I'll also create one document where I'll write all of my learnings. what might be the best place to note down? Yeah, let's create a Google Doc, right? Google Doc would be all right, I think. The issue with the tuple code in listing 4 to 5 is that we have to return the string to the calling function, so we can still use the string after the call to calculate length. No, give what? References in Rust allow us to point to a resource without owning it. This means that the original owner of the resource remains the same. References are helpful when passing values to a function that we do not want to change the ownership of. Creating a reference is known as borrowing in Rust. Okay, ownership and borrowing. Okay. Let me create a Google Doc real quick. Okay, that's all for today's stream. I'll write some notes and I'll just go to sleep. That's all. Thanks. Thank you.